Hey everyone, welcome to Ox Tutoring. I hope you're having a great day. Today we are doing question 7 from chapter 4G. This is a simple question, but an odd one. So that's why I want to go through it. Okay, so let's start the question. Question 7. Find the solutions of the equation z to the power of 8 plus 1 equals to 0 in polar form. So we just basically want to solve for z. And we know that there should be 8 answers because it's to the power of 8. If there's to the power of 7, you get 7 answers and so on. And then second part is we need to factorize the exact same expression, okay, z to the power of 8 plus 1. So let's go through the first part. Whenever you see z to the degree of power bigger than 3, so 4 or higher, you usually want to use de Moivre's theorem, okay? So we'll go through de Moivre's theorem as we go along this question. Right, so let's write the question down. Z to the power of 8 plus 1 equals to 0. So with de Moivre's theorem, or using de Moivre's theorem to help you solve this question, you always want to make z the subject every time, okay? So in this case, z to the power of 8, make it to the one side, left-hand side, and you shift everything else to the other side. So that 1 becomes a negative 1, okay? And with de Moivre's theorem, you need everything in polar form, okay? So if you want everything in polar form, we need to convert this negative 1 into its, so that's the Cartesian form, we need to convert that into its polar form. How would you convert that to polar form? Well, we know that if you want to convert something to polar, there are two components. First, you need to find r. R in this case is very simple. It is square root of the real square, so in this case negative 1 square, plus the imaginary square, which in this case is just 0i, so that is just 0 square, and at the end you should get r equals 1. 1 is very simple, that's why it's our favorite number. If you want to find r, it's just the same thing, okay? And argument on the other hand, a little bit harder. So negative 1 real is over here, okay, on your unit circle. And over here, the angle is pi. So essentially, theta equals to pi. Make sure it's in your argument. It shouldn't be too bad. Your argument is between negative pi to pi. It is within your argument, and that's fine, okay? So a way to write negative 1 in terms of polar form is cis pi, okay? And that's it. Make sure whenever you write something in polar form, you should never have a negative coefficient in front of cis, okay? Because you cannot have a negative length. R is essentially your length, your radius. Right, so let's proceed to solve for z. There should be 8 answers, and let's go through it. So also, just a quick tip, whenever you want to use de Moivre's theorem, you want to write this cis right here with a 2 pi k, so plus 2 pi k every time, okay? So that's also one of the requirements before I forget. Right, so if you want to solve for it, it's z. We make z by itself, and then we want to get rid of the to the power of 8 here, so you you root 1 over 8. So 1 to the power of 1 on 8 is just 1s, because 1 just becomes 1 itself whenever you square root or cube root or 8 root it. And inside, using de Moivre's theorem, so another way of writing this is essentially cis pi plus 2 pi k to the power of 1 on 8, and of course that gives us cis pi on 8, so it's just multiplying the power in, plus pi k, or in this case actually I'll put 2 pi k on 8 to make it simple when we're adding, okay? Right, so that is your form, and if you want to get the first answer, you let k equals to 0, and if you let k equals 0, you get z equals to cis pi on 8, and then you keep going on, let k equals 1, and I'll do this quickly, just add, just sub in k equals 1, sub in k equals 2 into this expression right here. So that's 3 pi on 8, and then k equals 2, that is z equals to cis, so that is 5 pi on 8, and then k equals to 3, z equals to cis, 7 pi on 8, and then keep going on, k equals to 4, z equals to cis, 4, that would be 9 pi on 8. Right, so 9 pi on 8 exceeds the argument, right? So argument can only be between negative pi to pi. 9 pi on 8 is way above, so maybe somewhere here. So if you want to convert it back, so that it's in the argument, you have to minus 2 pi, okay? So that is equals to cis 9 pi on 8 minus 2 pi, that should give us, let's see, 8, that is negative 7 pi on 8, okay? So 9 pi minus 16 gives us negative 7 pi, okay? Negative 7 pi on 8. Right, and another strategy, if you know that if k equals 4 is going to exceed, so when you sub in k equals 4, it's going to exceed the argument, you can sub in k equals negative 1 instead. So go the reverse route, okay? So you can do that too. Or you can just proceed 0, 1, 2, 3, 4, and then sub in 5, sub in 6, sub. So that's our 8 answers, okay? So 8 answers, all good. We finished our first part. So the question says, find the solutions in polar form. So when they say solution, I want to make this very clear, okay? In the exam, it's also crucial. When they say solution, your answer should be z equals to an answer, okay? So something. But on the second part, when they say hence, factorize, so factorize, or another word for that is hence find the factors, then what you want to do is you do not want to have an equal sign anymore. So this is 8 solutions. And if you want to convert this to factors, or if you want to write it in factors, you should not have an equal sign anymore. What you do is just bring the cis, or whatever answer you have here, the solution, move it to the left hand side. Bring it so that it's with z, okay? So that's z minus cis pi on 8. That is a factor. So that's one factor, okay? That's a factor. Right, and if you want to find the other 7 factors, all you have to do is just shift them to the other side as well. And there we go. That is your second factor, okay? You keep doing that for all the other solutions, and that's how you find the factors or the second part of this question, okay? So just one thing, make sure, just be careful, solutions, or the other name for it, you might see roots, that's the same as solutions, is not the same as factor, okay? So just be careful with that in your exam, in your SAC, or even when you're doing questions from your textbook. But aside from that, guys, just wanted to teach you that, and thanks for watching. I'll see you in the next video.